Okay, good morning, class. Let's continue with the second part of this Anova, where we will be cover on Chefe test and also Tukey test. Okay, so let's go on with part two. Okay, part two. The Chefe test and Tukey test. When the null hypothesis is rejected using F test, the researcher may want to know where is the difference among the mean is. Okay, just now the hypothesis testing in part 1 is just to saying that okay, there is a difference. Okay, but these two tests basically to identify where is the difference among the data set, okay, among the sample. The Chaffee test and the Tukey test are procedures to determine where the significant differences in the means lie after the Anova procedure has been performed. This is what I explained just now. So, Chaffee test. In order to conduct Chaffee test, one must compare the means two at a time using all possible combinations. So we have three different combinations, three samples. So we just compare the time that we learn about the probability, right? So all the possibilities that we apply. Okay, so for example, if there are three means, okay, the following comparison must be done: x versus 1, x versus 2, x versus x1 versus x2, x1 versus x3, x1 versus no more, so x2 versus x3, x1 versus x2. It's already here, so you don't have to repeat it, so just let it be there. One time is enough. Okay, and the formula for the Chaffee test will be fs is equal to xi bar minus xj bar square divided by standard deviation, variance of within sample, okay, within group variance times with 1 divided by ni plus 1 divided by nj. Okay, close the bracket and close the square bracket. We'll see example. And also the f value for the Chaffee test. In order to define the critical value for f prime for the Chaffee test, multiply the critical value for f test by k minus 1 times with critical value. Obviously the critical value is come from the distribution table. There is a significant difference between the two means being compared when fs is greater than the f prime. Okay, let's see an example. Using the Chaffee test each pair of means in example 1 just now, right? Okay, to see where the specific difference exists at alpha 0.05. So for the first one, as a solution, we have to do for all the possibility of versus. So x1 versus x2, just use the formula. So x1, the mean is 11.8 minus 3.8 squared divided by the variance 8.73. Okay, so the variance 8.73. Let's see where is the variance is come from. Example number 1. This one. Okay, within the error. Okay, within this one, mean square. So we got this. So 1 divided by 5 plus 1 divided by 5 2 times, because we have a 2 sample. Okay, x1 and x2. So you will get the value 18.33. So the same thing is applied when it's come to x2 versus x3, x1 versus x3 as well. So you will get 4.14, 5.04, 5. Next, the critical value for the analysis of variance. Okay, not 12, it should be example 1 was 3.89. Just now when we calculate, from the table, example number 1, we got 3.89. This one is the test value, okay, manual calculation. But based on the table, how much we got? 3.89. Okay, this one, the critical values come from the table. So for that, by using table H alpha 0.05, dfn and k minus 1 is equal to 2, 3 minus 1, and then n minus k, which is 15 minus 3, you'll get 12. So in this case, it is multiplied by k minus 1, which is 3 minus 1, times with 3.89 is equal to 7.78. Since only the f test value for a part A, x1 versus x2 is greater than the critical value. Okay, where's the critical value? Critical value here in this case 7.78, and they mentioned that x1 versus x2, which is 18, which is greater than 7.78. So the only significant difference between x1 x2, that is between medication and exercise. So where the the difference is actually lie in between x1 versus x2. Okay, next example, we'll continue with okay, these additional notes I think you guys can go through yourself. I'll go on with Tukey tests. Tukey tests can also be used after the analysis of variance. Okay, Anova has been completed to make pairwise comparison between means when the groups have the same sample size. The symbol for the test value, Tukey test, is Q. Okay, this one. For the Cephei test is F, right? So this one is Q. So xi bar minus xj bar divided by variance of within sample divided by n square root. Okay, so we're going to use the same example 1. We will check on x1 minus x2 divided by variance in bracket, variance divided by 5, okay, n square root. So you will get 6.06. So same apply for x versus x1 versus x3, x2 versus x3 as well. So you'll get one is 3.18, negative 2.88. So how to summarize this? Okay, let's see. To find the critical value of Tukey test, use table N. Okay, just now we reached table H, right? This one is table N in appendix C. Okay, so the number of mean K is found. Okay, usually the table name is given as Tukey table, so don't get confused. So the degree of freedom for within variance are found in the left column denoted by V. Okay, your left, this one is your left, and this one is your right side. So on top lah, this one is top. Okay, upper part or something lah. Since K equal to 3 and DF is equal to 12, alpha 0.05, the critical value is 3.77. Hence, the only Q value that is greater than the absolute value, okay, 3.377, it's between this This one also less than 3.77, less than 3.77. The greater one is 6.06, greater than 3 where is the value, 3.77, which means the difference lie between x1 versus x2. Okay, so the conclusion then is there a significant difference means of medication and exercise. This result agree with the Sheffer analysis. Previously, the Sheffer analysis also got x1 versus x2, right? Same thing for the two key tests as well. So we got the same answer. Okay, so that's all about part 2. We'll continue with part 3 after this. Thank you, class.